Hello friends, my name is Manoj Chaudhary and welcome to this next lecture on determinants. So if you remember in my previous videos, we already discussed about a 2 by 2 determinant and 3 by 3 determinant. Now this is altogether a different topic that we are studying today. So let's try to understand the different properties of determinants. So let's start with property number 1. Right, so the first property is, so please read it very carefully, the value of determinant remains same if all of its rows and columns are interchanged. Now let's try to understand the meaning of this property with this simple example. So here I am taking the expansion of this determinant along the first row. Let's try to find the value of this determinant first. So this is 3 times, then I'm taking this cross, it's a 1 into 1 is 1, minus this 3 into minus 2 is minus 6. Then in terms of middle term, always change the sign, minus 4 becomes plus 4, and then expansion along this minus 4 is this cross multiplication of 1 into 1 is 1, then cross multiplication of 2 with minus 2 is minus 4. Then the last expansion along this 5 is this cross 1 into 3 is 3 minus, then this cross 2 into 1 is 2, right? Okay, now let's simplify and find out this value of determinant. Once we got this value, we will check this property then. So it's a 7 over here, this is 4 times 5 and it's a 5 times 1. So here I'm putting all the calculations in detail. This one is 21, 20 and 5. So what is your observation, friends? So what is the final answer for this determinant? So final answer for this determinant is 46. So here we got final answer for this determinant equal to 46. Now let's try to understand this property. So once again here I am reading this property for you. The value of determinant, so please try to read. The value of determinant remains same if we interchange all the rows and columns of that determinant. Now they want us to interchange all the rows and columns of the determinant. So now rows are horizontal. So this is the row 1, 3 minus 4, 5. Then the row 2 elements are 1, 1 minus 2. And row 3 elements are 2, 3, 1. So rows are horizontal. So this is the row 1. This one is a row 2. This one is a row 3. Now here I am marking these columns also. So if you observe, the columns are C1, C2, C3. So elements under the column 1 are 3, 1, 2. Elements under the column 2 are minus 4, 1, 3. And elements under the column 3 are 5, minus 2, 1. So right now, so here I am removing this thing. So because we know the value of determinant now. Now as per this property, they want us to change all the rows and column of this determinant. So please understand this. So here I am interchanging all the rows and columns. So now convert this first row into first column. So understand this. Let's convert this row into first column. So here I am interchanging all the rows and all the columns of this determinant. So let's see what will happen. So friends, if you observe, this is the row 1. This is 3 minus 4, 5. Now I'm converting that into a column. So this is 3 minus 4, 5. So please observe this very carefully. This is 3 minus 4, 5, which is a row. Now here I converted that first row into first column. Now what about the second row? Second row is 1, 1 minus 2. Let's convert this into second column. So second row becomes second column. Then let's convert this third row into third column. So third column becomes 2, 3, 1. And according to them, even though we interchange all the rows and columns of this determinant, still the value of determinant remains same. So let's cross verify this. Here I am taking the expansion of this determinant along the first row. So expansion along this 3 is, this 1 into 1 is 1, minus 2 into 3 is minus 6. Then you know the middle term, that is 1. Always change the sign of the middle term. So 1 becomes minus 1. Then this cross, minus 4 into 1 is minus 4. Minus this 5 into 3 is 15. Plus the last element is of first row is 2. Now expansion along this 2 is this cross. Minus 4 into minus 2 is plus 8. Minus 5 into 1 is 5. Now let's solve this thing. This is 3 into 7. Minus 1 into minus 19 plus twice of, is it 3? Okay, then this one is 21. It's a plus 19 plus 6. Now let's cross check. So please observe here, this is 21. What is 19 plus 6? Is it 25? Now what is 25 plus 21? This is equal to 46. And if you observe the original value of the determinant, if you check the original value of determinant, it was also 46. Then what is this property is exactly suggesting? So as per this property, if we interchange all the rows and columns of a determinant, so if you observe here, I am converting all the rows. So this row 1 becomes column 1. This row 2 is now a column 2. And this row 3 is now a column 3. And vice versa, if you observe this column 3, 1, 2, now it is a first row. This is a column 2 minus 4, 1, 3. Now it is a second row. And if you observe this column 3, which is 5 minus 2, 1, now it is a third row. So in the sense, they want us to change all the rows and columns of a determinant. And even though if you interchange all the rows, so here I am focusing on the word all. If you interchange all the rows and all the columns of a determinant, then the value of determinant remains same. So that's all. This is all about this property number 1. So once again here I am repeating, if you interchange all the rows and columns of a determinant, then the value of determinant remains same. Now let's understand this property number 2. So property number 2 is, let's read it first. If two rows or two columns of a determinant are interchanged, then the value of determinant changes by sign only. Sign in the sense they want us to suggest by plus minus. Now let's understand this thing. Now in previous property we interchanged all the rows and columns of determinant. Now in this case they want us to change only two rows or any two columns of a determinant, right? Okay, now this is the determinant. Once again, the same determinant I am covering here. So if you observe, this is the original determinant whose determinant value is 46. Same determinant here I copied, and its value you already know, so I'm not going to waste your time in finding the value of this determinant. So value of this determinant is 46. Now they want us to change any two rows or any two columns of a determinant. Now let's interchange the two rows. So let's say this is the row 1 and this is row 2, this one is row 3. Now friends, here I'm going to interchange the positions of two rows. So let's interchange the position of row 1 and row 2, and I'm keeping this row 3 as it is. So don't change the position of R3, just keep this R3 as it is and only interchange the position of two rows, that is R1, R2. Now this row 2, if you observe this row 2 which is 1, 1 minus 2, let's convert this into first now. So it's a 1, 1 minus to become the first row. Now the first row which was 3 minus 4, 5, now it becomes second row with this 3 minus 4 minus 5. And here I am keeping the third row as it is, which is 2, 3, 1. So please observe these changes. So this is 2, 3, 1, which is the third row. I am keeping this one as it is. And here this one is the first row. So now here I am converting this first row into a second row. And the second row becomes first row. In the sense we interchanged the position of the two rows, R1 with R2 or R2 with R1, by keeping the third row as it is. Now according to them, if you interchange the position of any two rows or two columns of a determinant, then the value of determinant changes by sign. So if you observe this previous answer, it was 46 and its sign is positive. So what do you think, what will be the next answer for this property? So answer remains same as per the digit. It remains 46. Only thing is this sign will change. Previously it's a plus. Now just make it minus. So final answer for this determinant is minus 46. Let's cross check with the expansion. So here I'm taking the expansion along this 1. So is it 1 times, then this cross minus 4 minus, this is 3 into 5 is 15. Then as per this middle digit, change its sign, minus 1. Then expansion along this 1 is, this 3 into 1 is 3 minus this 2 into 5 is 10, right? Okay, then further expansion along this minus 2 is 3 into 3 is 9 minus 2 into minus 4 is minus 8. Now let's try to find its value. So if you observe, it's minus 19. Over here, if you observe, this is minus 1 into minus 7. This is minus 2 into 17, right? Further, this is minus 19 plus 7 and minus 34. So what is your observation? So this minus 19 plus 7 is minus 12. This is minus 34, and minus 12 minus 34 is minus 46, right? Now here if you observe, the value remains same, only thing is the sign changes. If you observe, the original value of the determinant was plus 46 and the new answer is, if you observe, this new answer is minus 46. So this is the difference between these two values. So value remains same, only thing is it changes the sign. Now let's understand the meaning of this particular property. So according to this property number 2, if you interchange any two rows, or the same property is also applicable for columns too. So but just change the two rows or two columns, right? If you want, you can apply the same property to columns also. So whatever the properties that we are discussing today, all the properties are applicable for row as well as column. So now here, this is the example where I explain each and everything with row, but let me tell you friends, the same property you can apply for columns too. Now what this property is suggesting, if you change the two rows or two columns of a determinant, then the value of determinant changes by sign only. This word is very important. The value of determinant changes by sign. Sign in the sense, if the value of original determinant is plus 46, then the value of new determinant is minus 46. If the value of original determinant is, let's say, with the minus 5, then the value of new determinant will be plus 5. So there will be a change in terms of sign only if you interchange any two rows or two columns of determinant. So I hope every one of you got this problem. So same property, if you want, you can apply for column also. Now if you, let's copy the same determinant again. So here I am copying the same determinant, and if you want, you can apply this property to columns too. So let's understand this thing. So friends, here this is the original determinant, let's say, and instead of changing the row, now this time here I am changing two columns. So you can change any two columns. So here I am interchanging the position of C2 with C3, means I am keeping C1 as it is. So let's keep this C1 as it is, and let's interchange the position of C2 and C3. So please observe this change. So here I am keeping the first row as it is. So let's keep this first row as it is, first column as it is, because we don't want to change anything as per in column number 1. Now here I am keeping this column number 1 as it is. Only thing that we want to do is we want to interchange these two columns. So friends, columns are vertical, so make sure that this column 2 becomes column 3 and this column 3 becomes column 2. Now here I am changing this column 3 to this column 2. So this column 3 elements, 5 minus 2 1, now it becomes a part of second column. So 5 minus 2 1 is now a second column. Now what about this second column? Minus 4 1 3, it will be a part of third column. So minus 4 1 3 is a third column. So right now, if you observe, we interchanged the position of the two columns, right? So columns are vertical, so please observe, this one was the column 3, now it is a column number 2. And if you observe, this one was the column 2, now here it is present. So if you observe, so here I interchanged the position of two columns. Now according to them, if you interchange any two rows or two columns of a determinant, then its value remains same, original value remains same, original digit remains same. Only thing is its answer changes by sign. So previous answer is with the plus sign and new answer will be minus 46. And if the original answer is, let's say, minus 5, then the new answer will be plus 5. So this is the thing that you have to observe while applying this property. So once again, here I am repeating this property number 2. If you interchange any two rows or two columns of a determinant, then its value changes by sign. Now let's understand the property number 3. So property number 3 is, if any two rows or two columns of a determinant are identical, or if you want, you can say same. If any two rows or two columns of a determinants are exactly similar, then very interesting result, then its value is 0. So please observe this thing, then its value is 0. Now let's understand this thing with this simple example. So if you observe this first row with these elements 2, 3, minus 1, this is the first row, and if you observe the second row with the same element 2, 3, minus 1. So if you observe the row 1 and row 2, so row 3 is altogether different, but row 1 elements and row 2 elements are exactly similar, right? So if any two rows or two columns of a determinants are identical or same, then the value of determinant becomes 0 as per this property. Now let's cross check it with simplification. So here I am taking the expansion of this determinant along this 2. So 2 into this cross 4 into 3 is 12 minus 7 into minus 1 is minus 7. Then here I am taking expansion along this 3, but don't forget to change its sign. It's a minus 3 times. Now the expansion along this 3 is this cross 2 into 4 is 8 minus this 1 into minus 1 is minus 1. Then the last expansion is along this minus 1, and then let's apply this cross. 2 into 7 is 14 minus 1 into 3 is 3. Now let's check whether it's really coming 0 or not. So final answer must be 0. It's a twice of, is it 19 minus 3 times this one is 9, and over here this is 11. So if you simplify it, this is 38 minus 27 minus 11, right? So is it 38 minus 27 minus 11 is minus 38, and 38 minus 38 is 0, and here we got the final answer for this problem equal to 0. Now what is your observation, friends? This is very simple, very interesting property. If any two rows or two columns of a determinant are exactly similar or identical, then the value of determinant becomes 0. So here if you observe, this row 1 and row 2 elements are exactly similar, and after expansion here we got the value of 0. So don't waste your time in doing this kind of expansions in examination. Just make sure that all the elements of row 1 and row 2 are similar. Once they are similar, you can consider its answer equal to 0. Now let's understand the same property for this column 2. So here if I keep, here I am keeping the column 1 as 2, 5, minus 3. I am changing the column number 2 as 1, 3, 7, and keeping this column 3 as 2, 5, minus 3. So what will be the final answer for this determinant? If you observe this particular determinant column wise, and here if you observe the first column elements are 2, 5, minus 3, and column 3 elements are also 2, 5, minus 3. Only thing which is different over here is the column 2. But as per this property, if any two rows or two columns of a determinant are exactly similar, then the value of determinant is always 0. So I hope every one of you got this meaning of property number 3. So these properties definitely will help you in different problems of determinant. So it will definitely, these properties will save your time in doing the calculations. Now let's understand property number 4, triangle property. Now if you observe, let's read it first and then we will understand. If all the elements above or below the diagonal are 0, then the value of determinant is equal to product of its diagonal elements. Now let me explain you this thing in a simple language. So if you observe this determinant, this 2, 1, minus 5 acts as its diagonal. Now why we say these are the diagonals? Because 2 is a part of first row, first column. So it's an element of first row, first column. If you observe this 1, it is a part of second row, second column. If you observe this 5, it is a part of third row, third column. So now this 2 is location wise, it is a part of first row, first column. If you observe this 1, it is a part of second row, second column, and this 5 is a part of third row, third column. So therefore we say 2, 1, 5 are nothing but the diagonal. So please observe that there is only one diagonal present to the determinant. We cannot say this is the diagonal because the elements are like 1, 3, 2, 2, and 3, 1. There is a complete mismatch along this. So therefore, as far as determinant is concerned, only one diagonal is present, and that is nothing but this one. So this is nothing but the diagonal of this determinant. And if you observe, all the elements below the diagonal are 0, and it forms a triangle. Please observe this thing very carefully. All the elements below this diagonal are 0. This is the thing that you have to observe. All the elements below this diagonal are 0. And as per this property, if all the elements above or below the diagonal are 0, then the value of determinant is always equal to the product of its diagonal elements. So now, according to this property, final answer is always a product of these diagonal elements, means final answer is 2 into 1 into 5, that is final answer is 10 for this determinant, right? Now, if you observe why this is called triangle property, the reason quite lies over here in the structure. If you observe, if all the elements below the diagonal are 0, it looks like a triangular 0 pattern. So now, therefore, they say it's a triangular property, but always remember, it always saves your time. Different properties always saves your time in simplification. So, as per this property, if all the elements below the diagonal, or if you observe this next problem, all the elements above the diagonal are 0. So let me form a triangle over here. If you observe, this is the triangle that they are talking about, and if you observe all the elements above the diagonal are 0, then the value of such a determinant is always product of their diagonal elements. And if you observe, these diagonal elements are minus 1, 4, 3, and its answer is always the product of diagonal elements. So in this case, it is minus 12. So final answer for this determinant is minus 12. So this is very simple property. So if you want, you can cross check its answer with any simple examples. So like this one that I consider. So please expand along this first row and find out your answers. Here I am confirming these answers. Let's talk about this first one. So let's take an expansion along these two. It's a twice of 1 into 5 is 5, minus 0 into 9 is 0. Then expansion along this 3 with the change of sign, it's a minus 3 into, is it 0 minus 0, and expansion along this last 4 is 0 minus 0. So friends, what is your observation? This one is 10, this one is 0, this one is also 0. So final answer is 10. So there is no need to take an expansion and all, but please observe that this property definitely will save your time of doing this kind of expansions. So I never recommend this kind of expansions once you observe this kind of things in examination. So here completely discard this kind of expansions if you observe this type of determinant whose please observe the diagonal, and all the elements below the diagonal are 0, or all the elements above the diagonal are 0, then the value of such a determinant is always a product of these diagonal elements. So similarly over here, if you multiply diagonal elements, that will directly give you answer for final determinants. Now I hope every one of you got this meaning of property number 4. Let's switch over to the next one, that is property number 5. Now in property number 5, we will see some rules related to the constants, how a constant plays a very important role in determinant. Now let's say this is the constant k whose value is 2, 3, 5. And these are the elements of first row a1, a2, a3. Second row is, let's say, b1, b2, b3. Third row is, let's say, c1, c2, c3. Now this constant k is present in multiplication with this determinant. Then what are the rules of the constant that you have to follow in the determinant? The first thing is, if you want, you can multiply this constant. If you want, you can multiply this constant to any particular row or any particular column. So friends, please observe this thing very carefully. If you want, you can multiply this k to the first particular row or second or third, whichever you want. So let's multiply this k to the second row. So keeping the first row as it is, even I am keeping the third row as it is. Let's multiply k to the second row. It's a k times b1, k times b2, k times b3. So what is your observation? So if you want to multiply any constant inside the determinant, make sure that you multiply it with any particular row. Or if you want, you can multiply that constant to any particular column. So whichever you want, as per the requirement of the problem. If you want, you can multiply that k to one particular column too. So here I am keeping the first column as it is, a1, b1, c1. Even I am keeping the third column as it is, which is a3, b3, c3. And let's multiply this k to this first column. It becomes k times a2, k times b2, and k times c2. So please observe this thing very carefully. Now, what is the rule of constant if you want to multiply inside a determinant? So the rule is quite simple. If you want to multiply, so here I am repeating a very, very important sentence. If you want to multiply a constant inside the determinant, then you are allowed to multiply it to one particular row or one particular column, whichever you want, but make sure that you multiply it with only one row. Now let's understand this, and on you have to take a judgment on the basis of requirement of the problem to which particular row is you want to select, right? So let's say this is the 2, and over here if you observe, this is x, y, z, p, q, r, and let's say it's a b, c. Now friends, if you want to multiply this 2 to this particular determinant, then you have a choice. If you want, you can multiply this 2 to this particular first row, or if you want, you can multiply to the second row, or if you want, you can multiply to this third row, or if you want, you can multiply this to this first column or second column or third column, whichever you want, but make sure that it is the requirement of the problem. So we always multiply these constants inside the determinant as per the requirement of the problem. Now let's say the requirement of the problem is multiplication of this 2 with this third row. Then just keep the first row as it is. Let's keep the second row as it is. Multiply this 2 with the third row. It becomes 2a, 2b, 2c. But make sure that you multiply that constant to one particular row only. Or if you want, you can multiply this thing to the one column, whichever you want. If you want, you can multiply this 2 to this first column itself. So it's a 2x, 2p, 2a, but make sure that you keep all the columns, rest of the columns as it is. Now what you get from this particular property is, if you want to multiply any constant inside the determinant, then please multiply it to one particular row or one particular column of your choice, and keep rest of the row and columns as it is. Now in exactly opposite way, if I say, if you want to take a constant common from this row or column, then make sure that that constant is common in that particular row or in that particular column. So if you want to take that constant outside the determinant. So let me explain you this thing with the simple example. So if I say the first row is 5, 7, minus 1, second row is 2, 10, and 12, and third row is, let's say, minus 1, 0, and 15. Now what is your observation, friends? If you observe this second row, in second row something is common, that is nothing but 2. So if you observe, it's a 5, 7, minus 1. This 2 we can express as 2 into 1, 10 we can express as 2 into 5, and 12 we can express as 2 into 6, keeping this third one as it is. Now if you observe, this 2 is common in each and every element of, if you observe, this 2 is common in each and every element of the second one. That is more than sufficient to take a constant outside the determinant. Now if you want, you can take this 2 outside the determinant, and finally you can mention the remaining determinant as 1, 5, 6, and minus 1, 0, 15. So please observe here, if something is common in particular row or particular column, you can take that constant outside the determinant too. So this is all what that I want to explain you about the rules related to constant in case of determinant. Now let's understand property number 7. So property number 7 is, if each element of any row or any column. So once again, here I want to tell you this very important fact: whatever the properties that we apply for the row are also applicable for the determinant or column too. So whatever the properties that you apply for the row are the same properties you can apply for columns. So there is no difference at all as far as rows and columns of determinants are concerned. So all the properties are applicable for the row as well as column. Now if each element of any row or column is expressed as a sum of two terms, then the determinant can be expressed as a sum of two different determinants. Now, this wording looks a little bit complicated, but let me tell you, the property itself is very, very simple. Now, here I am considering one determinant with sum of two elements like a plus x, b plus y, and c plus z. This is the first row. And I am keeping the rest of the row as it is, as p, q, r. And let's consider over here as A, capital G, capital X. I'm taking any random thing. Now, if you observe the first row is expressed as a sum of two elements. If you observe, this is sum means addition, right? So if you observe this particular first row of this determinant, every element of this determinant is expressed as a sum of two terms. Then according to this property, you can split this determinant into two separate determinants, and while separating these two determinant, make sure that you keep this rest of these two rows as it is. It has nothing to do with this property. So here I am keeping this PQR as it is in both the determinant. Even I am keeping this AG and H as it is in the determinant. So let's keep this PQR as it is. Then let's keep this AGH as it is. Now this property only belongs to this first row, which is expressed as a sum of two elements. If you observe, this is the sum of two elements. Here also, if you observe, this is expressed as a sum of two elements. Then you can split this into two parts. Now let's write this A, B and C in first determinant. So please observe this thing. So let me mark with a different arrow. This is A, this one is B, this one is C, and here I express this A, B, C in a first determinant. Now what about the second element? So please observe the second element. Let me mark it with different symbol, different color. So this is X, this is Y, this is Z. Now you can express this X, Y, Z in second determinant. So now what this property is telling about this thing is, if any particular row or any particular column of a determinant is expressed as a sum of two elements. If you observe, this is the sum of two elements, then you can split this kind of determinants into two parts, right? In first part, make sure that you take all first elements, and in second part you can take all second elements by keeping, and please observe here I am keeping the second row as it is, even I am keeping the third row as it is. Same rule you can apply for column 2. Let's understand the same property with the column. So let's say this is ABC, and here in the second column it is expressed as X plus P, Y plus Q and Z plus R, and here I am keeping this AGH as it is. Now if you observe the second row, which is expressed as a sum of two elements, then you can split this kind of determinants into two separate determinants. Just keep a first column as it is, even keep the last column, that is third column, as it is in both the determinant. Now only thing is, if you observe this first part of this sum, that is X, Y and Z, let's express this in first determinant, and whatever is the second one, that is I'm talking about P, Q and R, let's write this P, Q and R in second determinant. Now this is the thing that they want to express from this property, that if each element of any row or any column is expressed as a sum of two terms, then the determinant can be expressed as sum of two different determinants in this way. So here I explain it with one example of row as well as with column. Now I hope with this explanation you got all the 7 properties of determinant. So friends, please observe, here we discussed all very important 7 properties of determinant. Definitely all these properties will help you in simplifying the property. So please revise this video one more time, and definitely this will help you in simplification of determinants and simplification of problems on the determinants. So right, on this positive note, here I am ending this session on properties of determinant. In next session we will cover various applications of determinant. So please don't miss that video, and don't forget to like and share this video too. So thank you friends, thanks for joining, goodbye and take care.